we have one more presentation this morning from Dion, and then we will have a poster session from 11 to 12. And we have approximately 13 posters. As I mentioned, there might be at least one person presenting via Skype in the cyber 425.
Good morning, everyone. My name is Dion. I am a PhD candidate in the section of plant breeding and genetics in the School of Integrative Plant Sciences. And I TA a large introductory biology course called Investigative Biology Labs over there. In our course, we have around 400 students and we have 12 TAs. I'm one of those TAs. I teach 2 3-hour lab sections per week and have around 18 students per class. And in our course, we introduce several students to statistics, and most of them have not had any statistics experience before. So this is the first time they're taking any statistics class, and they find it hard to learn statistics in a biology course. So I thought maybe introducing them to science history of some of these statistical methods could inspire them to learn statistics in a better way. If you're wondering who these people are in this picture, so here's some science history for you. This is Francis Galton. He came up with regression. This is Carl Pearson, who first came up with Pearson's correlation. That's Ronald Fisher, who did analysis of variance or ANOVA. That's William Gossett, who came up with t-tests. So with each and every simple statistical methods we use, there are these really fun stories, or not fun stories, that could be really helpful in introducing students to these statistical methods. So the hypothesis was very simple. So if we wanted to inspire our students to learn statistical methods by introducing them to science history of these statistical methods. And this is not like the first thing. Science history has been used in several other fields to improve pedagogy, especially in physics labs to prevent dropout rates from students, and they have been successfully used in several occasions, and there's published literature to prove that. So we based our hypothesis based on that. So our study can be divided into 2 phases. The first phase was a small phase. I have this 2 small lab groups, so I thought I will start my hypothesis and study with that group. So I first taught my students statistics without any science history and asked them to rate their understanding, interest, and confidence from a scale of 1 to 10. And then I taught my students science history and statistics and asked them to rate their understanding, interest, and confidence. If you're wondering why I asked my students to rate their understanding, interest, and confidence from a scale of 1 to 10, I'm a corn breeder. So in corn breeding, usually we rate everything from a scale of 1 to 10. So I didn't use any Likert scale, so I'll do this and see what happens. So
I should sit right
I like to just, yeah, you should sit right
So the orange bar shows the interest level, confidence level, enjoyment, and understanding of students after they learn science history, and blue is before they learn science history. As you can see, there's not a very significant difference between these 2 groups, but there was a slight positive trend towards that. So, so I thought maybe we could, if the sample size was increased, maybe there will be a difference. But there are also several other limitations for this study. So it was obviously a small group, and then there were several students with prior statistics training, and students knew that they were a part of an experiment, so that might have confounded the experiment. I didn't collect any qualitative response. I just treated my students like corn plants, which is not cool. So in the phase 2 experiment, I had a better understanding of how to do qualitative research. So we decided to do a survey and collect information from all our students in our course about their thinking about science history, and if that will help them in their understanding of statistics. So we're going to ask the students about science history and use that information to add science history into our course. So, as you can see here, the first question was if they have taken a statistics course before our course, and several of them have taken statistics course, but also several of them have not taken a statistics course before, and the difference was very significant. And I asked them if they were curious about science history at all, of statistical methods, and without any surprise, no, they were not curious at all. But some students were extremely curious about science history, so I was like, okay, that's good. So I asked them if they thought knowing science history would increase their understanding of statistics. And several of them said it would increase their understanding moderately or slightly likely. And I asked if understanding of science history would improve their understanding of statistics, improve their confidence in statistical methods. And several of them said moderately or slightly likely. And I also asked if understanding of science history would improve their interest, and also said moderately or slightly likely. So most of them said, at least. And as you can see, the trend is similar for the 3 questions. So I did a Cronbach's alpha test and found that there is a good agreement between these 3 questions. So they think learning science history will moderately or slightly improve their understanding, confidence, and interest of statistics. In statistics. And we asked the students if they were they're more likely to take any statistics classes. And several of them said they were extremely likely to take more statistics classes. And I also asked some qualitative questions, as for example, I asked them if understanding of science history, why do they think that's important? And these responses kind of summarize what the other students mentioned. So understanding where statistics comes from helps you understand how to use statistical methods and statistics in general, which may help you extrapolate information from your data, which is what I thought also, so that was cool. And one of the other students said, I think learning about the mistakes from former statisticians have done or former methods that are no longer viable are important in understanding how to fine-tune and make current statistical methods better, which is, I think, very important since in biology the data has been increasing constantly. And like in 2015 there was a paper that was out and it said that data that's generated in biology is going to be higher than data that's generated in YouTube, Twitter, and astronomy combined. So that's a lot of data in genomics by 2025, which is not very far away. And the methods that are available to analyze these data are not increasing in that phase. So we need innovation in data analysis, and I think like helping students get in that mindset very early is very important. And my students think that too, so that's really good. And I asked them if they have a good learning method to learn statistics. And most of them said yes, they have a great learning method to learn statistics. So it's like, but there is also plenty of research that supports that students are not good evaluators of their own learning. So I was like, okay. So just from this study, what I got was most students are not curious about the history of statistical methods. Most students think science history will help them in improving their understanding, learning, and confidence of statistical methods. Most students have not taken a college-level statistics course, but they think they may take more statistics classes in future. And students think they have a good method to learn statistics. And at the end of it all, I think most students think learning statistics is important for their understanding. Well, learning science history is important for their understanding of statistics. In future, we will add science history to our instruction in some form, and we'll see if that helps them really improve their understanding, interest, and confidence in learning statistics. Thank you.